Good afternoon. So we'll now deal with the half of the chapter, the second half of the chapter, that is called as vectors. Now what is vector? Vector by definition it means a carrier, something that will take something from one place to another is what we call as vector. In a mathematical sense, it's going to give a direction, something that shows us a direction with some magnitude of it is called as vector. I'll tell you what it means. Before we actually start with the vectors and vector notation, let's see a very simple situation. There was one video where there was a relay race. There were school kids, small school kids, grade 3, 4 kids, and they were running. The relay race started, and the one bunch of boys started to run. Then they handed over the baton to the second bunch of boys. They started to run, and then they handed the baton to the third bunch of boys. Unfortunately, what happened is the leader of the pack, who was always the team which was winning the race, the last boy had been waiting for the baton and he wanted to run very hard. He took the baton and he started to run and he forgot the direction. In the sense that he should have been standing like this with his hand behind to take the baton and then start running. Instead, small kid he must have been, stood like this, facing the opposite side. The moment the baton, his friend came with the baton, he took the baton and started to run. He started running in opposite direction. This brings us back to the reality that no matter what, even if you run very fast, if you run in the wrong direction, you will not win. I might be here, my friend might call me and he might say, I am standing to this point, you called me here, I come to meet you. And if I tell him that I am just about 100 meters from that place, will he able to meet me? Will he find me? Just 100 meters from that place. 100 meter where? Are you expecting your friend to climb 100 meter upwards? Or should he dig down the earth 100 meter downwards? Or should he go towards the left or the right? Your left and right. Or ahead or behind. Which direction? Which way to go? So there are certain quantities that you cannot only tell 100 meter. You also have to specify the direction. Only then you can reach the appropriate spot. And that is what is called as vector. Vector is that quantity which has not only the distance or the weight, which we call as magnitude. It has its magnitude, it has its value, but it also has its direction. There are certain quantities which are called as scalars because there is no sense of direction in that. We never say ki I waited for 1 hour towards the east. 1 hour is time. Time has no direction. We don't need to specify the direction with time. I waited for 1 hour, that is good enough. I don't have to say towards the east, towards the west. But I walked 1 kilometer towards the east. Makes a lot of sense because if I walk towards the west, I will be reaching somewhere else. If I walk towards the north, I will be reaching somewhere else. So I have to specify the direction as well. Certain quantities need direction, these are called as vectors. Let's see what vector means. This is small vector A, this is vector B. And if we specify the starting point and the terminating point of the vector, A is the starting point where the vector started, B is the point of termination where the vector would terminate or end. Then it is written as AB bar, AB, and on top of that is an arrow, AB vector or AB bar. BA bar would have been the opposite vectors. They are opposite vectors. They are not same. We can see that AB is equal to BA in magnitude, in multiplication, in algebra. But in vectors, AB vector and BA vector are not same vectors. They are actually ulta opposite vectors. Absolutely. Writing the vectors and number pairs. Let's see this. This is P and Q. We know the value of P. The point P is denoted by 2, 2. The point Q is denoted by 4, 6. So the vector PQ, see it is starting from P and it is going up to Q. how much on the x-axis, how much on the x direction. As it goes from P to Q, it is going 2 units towards the right on the x-axis. So 2 places on x-axis and 4 places up, 4 places along the positive y-axis. So the magnitude is written as 2, 4. See how it is denoted. So you can write PQ bar is equal to 4, where in the round bracket you write a column vector where the topmost position is the change in the value of x and the bottom position is the change in the value of y, and that is how you write the vector. Express RS vector and LM vector as column vector. RS. See how much on the x-axis? 1, 2 and 3. And how much on the y-axis? 1, 2, 3, 4. So RS is written as 3, 4. See 3, 4. Not 3, 4, sorry, 3, 4. And LM vector, it is going on the right side. So 1, 2 and 3. So x is 3. But y is minus 2 because it is going towards the downward side. So 3 minus 2 is the vector. Draw the column vectors 1, 3 and minus 2, minus 4. This is 1, 3, minus 2, minus 4 on the opposite side. We see that. Not very difficult. Using the vectors to describe the translation, we already done that. You know, in the previous section, there are transformations. One of the transformation was translation, and we have written that as a vector. So this part is done. The column vector is 2, 3, where from R2 you get S. So starting point, this point will become by saying 2 transformations here to here, and this point on the y-axis will become 1, 2 and 3. So for this point to become this point, 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 and this point to become this point. Ultimately you need a transformation by which is denoted by the column vector 2, 3. The exercise is very simple. You can just go through it. 23.6 is extremely simple. Define the vectors. Write the column vector to denote this, to denote this. There is nothing. Represent these vectors on the paper, square paper. Make a graph paper like that and represent these vectors. Again, just far too easy. Write the column vectors for the following: AB bar and DC bar. AB bar. Just show this. And the AB bar will be the column vector for AB bar. Please pay attention to this. This is 1, 2, 3 and 4. And y-axis there is no change in the value of y. So 2, 0 is the AB vector. We can write it like this. So the column vector that shows AB bar can be written like this. AB bar 1, 2, 3, 4, 4, 0. Then we are asked about DC bar as well. So DC bar is going to be the same again. In a parallelogram, the opposite sides are parallel and equal in length. So the vectors will be absolutely same. So we get this will be also 1, 2, 3, 4, and no change in the value of y, so 0 here. Now BC bar and AD bar. This is 1. And AD bar will also be equal to 1 and 3. You can check that. Yeah, find a column vector which is showing the transformation. We can do that. There is nothing great about it. Equal vectors, the vectors which have the same, absolutely same values of one transformation. So this is 1 on x-axis and 2 on y-axis. Same here, 1, 2, 1, 2, 1, 2, 1, 2. Both these values must be equal, only then the vectors are equal. You cannot say that this is 1, 2. You can't say a vector 1, 2 and 2, 1 are equal. They are not equal. Both have to be equal. Only one being equal is not good enough. The addition, multiplication, that's not the logic at all. Then appropriate values have to match. Then they will be equal. Multiplying a vector by a scalar. So what is a vector? This, let's say AB bar is a vector here. And exactly double of that will become AC bar. AB bar into 2 will be AC bar. So you written AC bar will go twice of AB bar. But AB bar is 2 on X and 1 on Y. So 2 comma 1, 2, 1. So twice of AB bar is twice of 2, 1. Is 2 into 2, 4. 2 into 1, 2. 4, 2. That's what we get. So multiplying any vector xy by a scalar k will give us kx and ky. This is vector A, 3 minus 7, calculate 3A, 9 and minus 21, half of A, 3 by 2 minus 7 by 2 and so on. This is very easy. Will not be great difficulty at all. Addition of vectors is what we will start now in 2 minutes.